For our chapter 6 problem, I'm going to be converting the amount of energy, I'm going to be finding the amount of energy in one wavelength. So to do this, the question states a source of energy emits radiation of a wavelength of 752 nanometers. What is the energy in kilojoules of 1 mole of photons in this reaction? So our first step is we need to convert our nanometers into meters. So we're going to 752 nanometers is 10 to the negative 9th, and using our conversion rules, we know that we have to go 2 up on the scale, so 752 nanometers equals 7.52 meters. So now that we have our meters, we need to find the frequency. We have a formula for frequency, but it's not given to us directly, so we need to solve for it. So if our wavelength times our frequency equals our constant, which a constant is the speed of light, the number is 3.0 times 10 to the 8th, we can plug and chug and solve for x. And when we solve for x, we know that the frequency of this problem is going to be 3.98936 times 10 to the 4th. Next, we need to determine the energy levels, and so we know that we have an equation for this too. Energy is just going to be equal to Planck's constant times the velocity. So when we plug all of that in, we are going to solve for the energy. So you just multiply Planck's constant, which is 6.626 times 10 to the negative 34 joules per second, times 3.98936, because that was the number that we got for our frequency. And when we solve for that, we realize that our energy is 2.64335 times 10 to the negative 19th. But this is only the amount of energy for one photon. So if we're looking for the moles, for the energy of 1 mole, we know that we have to use Avogadro's number, which is 6.022 times 10 to the 23rd, and we're going to multiply that by the energy that we found, which is 2.64335 times 10 to the negative 19, and when we solve for that, we get 159182.6 joules per mole. But if you go back to the question, it's asking for it in kilojoules, so we simply just have to divide this number by 1000, and our final answer is 159.182 kilojoules per mole.